So in this experiment, we're going to do deflection test. I'm going to be pulling on this bar, and we'll be able to gauge just the amount of force that's being applied. Similar gauge to what I used yesterday. It's actually a fish scale. We're going to, as we pull, we're going to deflect this bar, and we're going to see if my epoxy and plate holds. I got a feeling this plastic shell is going to be deflecting quite a bit. So I want to get it up to a point. I don't want to break this because I got a few more tests, but we'll just see how much we can pull. Okay, we're at 1 pound. That shut off. Let me reset it. £12, 14 pounds, 16 pounds. I don't know if you can see that. 16 pounds, 18 pounds. You can see all the distortion that's taking place here. 19 pounds. Can we get to 20? 17. I'm not going any further than that. In fact, the bar is starting to bend in this location here. So that's pretty strong. All right, number 3 experiment. We're going to do a drop test. Got a 5-pound metal plate, which I'm going to let drop down onto the shell, and we'll see how well my repair holds up down in here. So we'll start out about 4 inches, we'll move up to 6, move up to 8, but I'm not going to change the weight. As the higher I go, the more velocity is going to be coming down. So let's start out about there. Alright, still holding. We'll get up to here. I'm kind of hitting here a little bit, but I can't do anything about that. That was a good hit. Still holding. And we'll take it up a little bit higher. Now it hit the... Let me see if I can hold it straighter. I don't know. It's a pretty good solid bond. I don't see anything that's broken. It's just holding strong. So I got one more test, which will be kind of interesting. So stay tuned. Okay, now on to the impact test. I've got 10-pound weight attached to my tether that's going to kind of pendulum across into this 2x2 square channel steel pipe. So this will probably destroy this thing, but we'll start giving it a try. I'm going to take it out to about 3 feet. About 4 feet. Further yet. I know, that's a lot of force. Can't get it to break. Yeah, what it did is it bent, I don't know if you can see it, it bent the metal. So, but the weld still held. So I think we're in good shape. If anybody wants to repair their ACM or any other shell that way, give it a try. It's going to hold up. Okay, we're going to do a torsion test to see just how this weld repair that I've made with the epoxy and the metal strut holds up. So we got our strut coming out. I've got a nut on the end. We're going to twist it. This torque wrench is right now set at 20 inch-pounds, so we'll see just how it works out. It should click when it achieves that particular level. Well, you can hear that there. So we got to 20. I got to put my glasses on for this, but we'll take it up to, there's 30 pounds. You can see it twisting. 30 pounds of torsion. There's 40. £40. Again, these are inch pounds. Here's 50 inch pounds. You can see it really twisting. Well, I got to 50. Starting to get a little deflection in the metal there. Definitely this is twisted. Well, we'll go to 60 and see what happens. There's 60 inch pounds. It's almost 80 or 90 degrees twisted. Yeah, that is remarkable. Okay, so the metal is completely twisted, almost 90 degrees, but the repair is definitely still holding. So that's a good sign. I'm pretty happy with this. So this little rivet that's down there, it became loose over this operation too. So, but this is the main strut that we're concerned about, and it's held up with all of our tests.